Hello, welcome back to Method 25. This is gonna be page 38. Method 25. And it's gonna be chapter, and it's for now we talk about like a volume. A chapter 6.2 is a volume by a washer and cross section. And so we call it washer as a call it washer method. We call it just volume by washer. So what we call this washer is the first time we need to find a volume bound by two curves. In previous section, we found the area bound by two curves. Is f of x and g of x. Here is f of x. Here is g of x. We know the area bound by the curve. It is here's a, here's b. It is b to the a. Top minus bottom is fx minus gx dx. For now, I'm going to talk about like a volume. How we find the volume is washer we do is the solid of revolution by a horizontal axis. So it's horizontal axis of rotation. That's why we call it like washers. So if we do an area found by f of, here's the two functions. F of x, g of x. Perhaps we rotate the area about the x-axis. So what is the volume? So if it's rotate about the x-axis, and there's two functions, and we call like outer radius and inner radius because this is a washer. The volume, it is equal to, here's intersection point A, intersection point B. B minus A, pi square we do is like r out is outer radius of squared minus the inner radius and just square dx. The outer radius, it is fx. Inner radius, it is g of x. So we can say if we rotate them by the x-axis, which is horizontal line y equals to 0, minus a 0. This is our radius. And we have is the volume is equal to BA pi of fx minus a 0 squared minus g of x minus a 0 squared to the dx. This is a volume. If we rotate them about the x-axis, that's how we find an area bound by on a region. If we rotate them about any horizontal axis, perhaps a function again this is h of x, k of x. If we rotate them by the horizontal line, perhaps y equals to -5. Then what is the volume of the area bounded by the curve rotate by the horizontal line? Rotate by horizontal line, y equals to -5. Horizontal line. Y equal to -5. Geez, I forgot the page number. So here is like a washer. So we can see here the radius is 5 and plus kx and hx minus 5 is the function. And so we have the outer radius it is h of x plus 5 because there are 5 the more than 5 radius. So typically the r out is the top function minus the radius, but now it's a negative. So negative, then it's positive. And in the radius is kx plus 5. Point here, still a and this b. Perhaps b is a 0. No, perhaps a is a 0 or non-zero term. And the volume we have it is b a to b pi r out hx plus 5 squared minus kx plus 5 squared dx. Here's some volume. Another one. If we have the axis of rotation is under the area of the solid. Now, what if we compute the volume of the solid bound by an area and the axis of rotation is above two curves. It's up. What if it's like up? They're above two curves. Perhaps they're y equal to 8. So what is the volume of the solid rotate about the horizontal line y equals -8? It's 8, not -8. Y equals to 8. Perhaps here's J of x, here's M of x. The radius should be 8 minus jx is the inner radius, and the outer radius should be 8 minus m of x is the outer radius. Our out it is 8 minus m of x. Inner radius should be 8 minus j of x. Then the volume of the solid rotate about the horizontal line y equals to 8. 8 is equal to it's still A and B. A minus m of x into the squared minus 8 minus j of x into the squared dx. It is the volume of the solid. Let's do an example here. Preferably, let's do one example here. Find the volume of the solid obtained by rotating the region bounded by f of x equal to x squared, vertical line, x equals to 2, about the x-axis. We do like a visual here. Here's x to the squared. Here's the x equal to 2 vertical line. You just rotate about the x-axis. So this is not a washer. So this is disk, or have only one function involved. Then we can do it is just like a washer. No, it's like disk. This is like the shape. I tried my best. It's not like a super perfect. It's not made by like graphic calculator. It's not made by like a online calculator. So we have is this actual 2 here is a 0, is using the use dx. Because they're all in terms of x, it is a horizontal axis of rotation. The radius is just the function in itself. It's like another type of volume, one function involved. So the volume is equal to b to the a pi to the fx square itself. We should call the radius function. In this case, the radius is just fx itself. So the volume of the solid bounded by the region should be upper bounds 2 and 0 as using the dx. Pi fx is equal to x squared to the squared dx. And we have, it is now it's just a basic integration. So it's all your work. go to 64, 32. Here's the volume bounded by x-axis because it's horizontal axis of rotation. Here's the volume bound by one curve. There's only one curve. Warning here. The volume equals to A to B pi f of x is 2. Forgot dx. I'm so sorry for the error. So only true if fx is the only curve is a function, not a line. Of the region of the enclosed region. Another example here. Page 41, this should be. Example number 2. Find the volume of the solid obtained by rotating, because it's like the region A. About the x-axis. And the region A, it is bound by the curve. F of x is 2x. G of x is x squared. Every time we have the volume problem, we draw like a visual graph. Two x. To the x squared, here is f of x, g of x. We rotate them about the x-axis, and this is a washer. So we use the formula is outer radius and the inner radius. So perhaps this is the only exam to try to do this problem on your own, and I will do the rest of it. Maybe try to pause the video. It's a washer. So we need to find outer radius. It is top function minus the x is a 0. So it is 2x. Inner radius, it is x squared. And find the point of intersection can be found find intersecting point is origin 2 and 4. They're all in terms of x. Use dx. The lower bound is 0, and upper bound is a 2. Upper bound is a 2. And here's the washer formula here. In the volume, it equal to from 0 to 2 pi outer radius 2x to the squared minus x squared to the squared dx. Here just all the basic integration here, and what we have is pi 2 and the 0 4x to the squared minus x to the 4th dx. And what we have is pi to the 3rd 2 and 0 minus pi. It is 1/5 x to the 5 power 2 and 0. And what we have it is 2 to the 8 32/3 pi minus the pi that we have, it is 15 160 minus 96 64 pi over 15. It is our final answer. The third example here. The region S is the area bounded by f of x equal to a square root of x, and gx it is equal to x. Find the volume of the solid obtained by by rotating the region S about the horizontal line y equals to -4. Maybe pause the video and try it on your own. Perhaps this is on the actual midterm. If we need to find outer radius, inner radius, the square root of x should be like this. Y equals to x should be like this. This is the gx. This is f of x. They're rotating about the horizontal line y equals to -4. And perhaps this is y equals to -4. Should be like a washer. This should be like a washer. Here's cross-section area. This should be like a washer rotated by the horizontal line y connected 4. The inner radius, outer radius, it is 4 plus f of x. Should be square root of x plus 4. Inside function should be x plus 4. Will be set up as their own term of x. Is horizontal axis of rotation. Find the point of intersection. Is a 0 and a 0 and a 1 and a 1. So we use upper bound, it is from 0 to 1 is our interval for bound. And we need to write integral here. The volume is equal to b minus a pi outer radius. It is the radical of x plus 4 to the squared minus x plus 4 to the squared dx. And then it's just the basic integration scales. X minus negative 7x plus 4 square root of x minus x squared, because this is canceled, equal to like a 0. And what we have, it is pi gonna be negative 7 over 2x to the squared, 1 and 0. This is x to the 1/2 to make sure the square root of x, it is x to the 1/2. 8 over 3, x to 3 over 2. 1 to the 0 times pi minus pi, 1/3 x to the cubic, 1 and 0. What we have it is -7 over 2 pi plus 8 over 3 pi minus 1/3 pi. So we have it as 7 over 2 pi plus 7 over 3 or pi here's a 1 and a 0, so it's going to be -4. We have make sure my should be 8, not 4. I'm so sorry for the mistake. $16. It's gonna be -3.5 minus 5. It's gonna be 3 over 2 pi. What if we do is like y equals to 4, then the outer radius should be 4 minus x, and the inner radius should be 4 minus radical x. Last example here. Region we call P is enclosed by the curve f of x. It is x to the cubic square and horizontal line y equals to 8. Find the volume of the solid obtained by rotating region P about the horizontal line y equals to 10 have have is this region. Maybe pause the video. Perhaps this is on the exam. Try it on your own. Here's the region. I'm trying to find here is going to be rotated by y equals to 10. The outer radius, it is 10 minus x to the cubic squared. The unit is 10 minus 8 is 2, it is inner radius. Use the dx. It look as like horizontal axis of rotation. Upper bound is from 0 to 2. So the integral should be volume of the integrand is 2 to 0 pi. Outer radius it is 10 minus x to the cubic squared minus 2 to the square root of 4 dx should be pi 0. It should be 100 minus 20x to the cubic minus x to the 6, then minus 4 dx is going to be pi to 100x 2 to the 0 minus going to be 5 to the 4 2 to the 0 minus 7x to the 7 to 0 times pi minus 4x 2 to 0. We have is 200 pi minus 2 to the 16 is 80 pi minus 2 to the 7th. It's 128. 128 or 7 pi minus going to be 8 pi. 112 pi minus 128 over 7 pi. What we have is 784 minus 128. It is equal to 656 or 7 pi. Okay, let's do a summary here, page 44. One, if it's a one function, and just rotate about the x-axis, then the volume is equal to b of b minus a pi to the radius function squared dx. Now the radius equal to function itself. Number two, it is one function is rotate about horizontal axis if axis of rotation it is above the x-axis, and then we have it is the outer radius is equal to the axis of rotation minus the bottom function. The inner radius, it is the axis of rotation minus the top function. And the volume, and number two, if the axis of rotation it is below the x-axis, the outer radius, it is top function minus the axis of rotation. Inner radius, it is the bottom function minus the radius, minus the axis of rotation. The volume should be b minus a pi outer radius to the squared minus inner radius to the squared. Dx. What if we have, what if there are two functions? There are two functions when I think to one function, the inner radius outer radius should be like a 0. Should be like maximize bottom function, inner radius should be outer should be like the wax should be like no, because it is a 0. The inner function is minus the top function. Axis rotation, so it's below the axis. Then the inner radius should be the axis of rotation. Sorry for the mistake. If it's the two functions, the other functions should be, if it's the other function, but it's rotate about y equals to something's positive, then and it's above the two functions and it's above. Same formula, but just the inner radius should be different. It's above the outer radius should be the axis of rotation minus the top minus the bottom function. The inner radius should be the axis of rotation minus the top function. I'm just stupid. Two functions. It is just to rotate about y equals to plus something. It is below. Then outer radius should be the top function minus the axis of rotation. Inner radius should be the bottom function minus the axis of rotation. So both 3 and 4 we have, it is the same as 2, but just the radius. Okay, here's the 6.2. It is the volume by washer and horizontal axis rotation. Next video will be 6.3, should be the axis by the shell method is vertical axis of rotation.